In this lesson, we'll be talking about the OSI and TCP IP models for network protocols and network stacks. OSI stands for Open Systems Interconnect, and in the late 1970s, they started working on a model for how a network stack and network protocols would look. Originally, the intent was to develop the model and then develop the protocols that went with it. What ended up happening was, after they developed the model, TCP/IP started really taking off, and the TCP/IP model that went along with it matched better what was going on with TCP/IP, which became the predominant protocol, and as a result, the OSI protocols never actually got developed. However, we still use the OSI model for a teaching tool as well as a way of describing what's going on within a network stack and in networked applications. You'll often hear people talking about the different layers, like that's a layer 2 problem, or we're in layer 3 space now. Continuing through these lessons, I'll refer occasionally to the different layers, and when I do that, I'm referring to the OSI model. So let's take a look at the OSI model. Starting from the bottom, we have the physical layer, which is where all of the physical stuff lives, the wires and cables and network interfaces and hubs and repeaters and switches and that sort of thing. Sitting above that is the data link layer, and that's where the Ethernet protocol, ATM protocol, frame relay, those sorts of things live. Now, I mentioned the switch below. Physically, the switch lives at layer 1, but it operates at layer 2. And the reason it operates at layer 2 is because it looks at the data link addresses, the layer 2 or physical address. And that's not to be confused with the physical layer. It does get a little mixed up sometimes. We refer to the MAC address on a system as the physical address because it lives on the physical interface and is bound physically to that interface. However, that MAC address, or media access control address, lives at layer 2 at the data link layer. The network layer, which is right above that at layer 3, that's where IP lives, as well as ICMP and IPX from the IPX/SPX suite of protocols from Novell. Routers operate at layer 3. Layer 4 above that is the transport layer. That's TCP, UDP, and SPX, again from the IPX/SPX suite of protocols. Above that is the session layer, that's layer 5, and that's AppleTalk and SSH as well as several other protocols. At the presentation layer, which is layer 6, you'll often see people refer to something like JPEG or MPEG as examples of protocols that live at that layer. Those are presentation layer protocols. And finally, we have layer 7, which is the application layer, and that's HTTP, FTP, SMTP, similar application protocols whose responsibility is to deliver end-user functionality. So that's the OSI model, and that's the 7 layers of the OSI model. There's some important things to note here. You'll see on the left-hand side there's some arrows, and what those suggest is when we are putting packets out onto the wire, the packet gets built from the top of the stack down, which is why it's called a stack. Each layer sits on top of the other. The application layer is responsible for beginning the process, and then that follows through the presentation session and transport layers and down through the network data link until we finally drop it on the wire at the physical layer. When it's received from the network, it goes from the bottom up. We receive it on the physical, it gets handled by the data link, then the network, transport, and so on. When going down or up, what we're dealing with is an encapsulation process. So at every layer on the way down, the different layers add bits of information to the datagram or the packet so that when it gets to the other side, each layer knows where its demarcation point is. And while it may seem obvious, each layer talks to the same layer on the other side. So when we drop a packet out onto the wire, the physical layer talks to the physical layer. In other words, the electrical bits that gets transmitted by the network interface on the first system are received on the second system. On the second system, the layer 2 headers that were put on by the first system get removed and handled as necessary. Same thing at the network layer. It's the network layer that puts on the IP headers, and it's the network layer that removes the IP headers and determines what to do from there, and so on. So again, while it may seem obvious, it's an important distinction to recognize that each layer talks to each layer. And when you're building a packet, you go down through the stack, and when you're receiving, you come up through the stack. And again, it's called a stack because we keep pushing things onto the top of the packet and they get popped off on the other side. So the OSI model. Let's move on to the TCP/IP model, which is on the right-hand side, and you'll notice that there's a really big difference here. That being that there are only 4 layers in the TCP/IP model as compared with the 7 layers of the OSI model. We have the network access layer, the internet layer, the transport layer, and the application layer. The functionality that the stack provides is the same. In other words, you're not going to get less functionality out of the TCP/IP model. It's just they've changed where different functionality resides and where the demarcation point between the different layers is. So there are only 4 layers in the TCP/IP model, which means that a couple of the layers have taken in functions from some of the OSI model. And we can get into that right here. The differences between the models at the network access layer in the TCP/IP model, that consists of the physical and the data link layer from the OSI model. So on the right here, you see the network access layer, and that takes into account the physical and data link layers from the OSI model on the left-hand side. Similarly, the application layer from the TCP/IP model encompasses the session, presentation, and application layers from the OSI model. So on the right, the very top box, the application layer, encompasses the session, presentation, and application layers on the left-hand side. And that, of course, leaves the transport layer to be the same, and in the OSI model, they call it the network layer. In the TCP/IP model, it's called the internet layer. Same sort of thing. That's where IP lives. And even though it's called the internet layer as compared to the network layer, it's the same sort of functionality. So those are the really big differences between the OSI and the TCP/IP model. Anytime I refer to layers through the course of the rest of these videos, I'm going to be referring to the OSI model, in part because it makes it easier to differentiate the different functionality. If I were to say the layer 1 function in the TCP/IP model, you wouldn't necessarily know if I was talking about a physical thing or a data link thing. Since there's more granularity in the OSI model, it's better to talk about the functionality in terms of the layers in the OSI model. And that's the 2 predominant models, the OSI model and the TCP/IP model, for network stacks and network protocols and applications.